Okay, we're going to get going here. Appreciate everyone taking the time this morning. My name is Keith DiStefano. I'm going to be taking you through a 30-minute webinar with my partner, Adam Hurt. I am a product marketing manager for our AppOptics products, and Adam is the product manager for AppOptics. That's our APM solution. Before we get going, I'm going to take you through this agenda, but while I'm doing that, we're going to be throwing up a series of polling questions, like 4 questions. We just want to get a sense for who we're talking to so we can do a better job as we go through the webinar. So if you'll take a shot and answer some of those polling questions while I take us through the agenda. So today's session is about troubleshooting with APM. First, we're going to talk a little bit about one of the major problems that APM is needed to solve and how that's maybe differed over the last few years. And I'm going to do something a little different. We're going to talk about troubleshooting with APM overall, but we're going to do a little bit of a deep dive on the components of tracing and how those components really facilitate troubleshooting bugs and errors in application code. Then I'm going to kind of bring it back up, and as many of you know, depending on who you are, if you're an engineer, if you're very intimate with the application, you're the one who wrote the code. The tools we're going to talk about that are part of an APM are extremely valuable in getting to the root cause of a problem, understanding how to improve performance. But the way things are changing today, things have expanded. The applications that are very different that we're building today, and the people to support them are very different. And so we're going to talk about how do you leverage an APM and to some extent take the complexity out of it so it can be leveraged by more than just someone who has an intimate knowledge of the application. So I'm kind of going to set us up there, and then Adam's going to knock it down by actually showing you these use cases and stories in practice. So let's talk about the problem. No real surprise here. I'm actually using a study that is a little bit dated, 2016. I just like the way this study, I don't know how many of you have seen this D-Zone study, but it talks a lot about developers and challenges they have. It says that 43% of application performance problems occur because of an issue with the code. And by the way, don't worry about it. Right behind that is the database. So I think it was 27% of the issues are caused by database. Seems like everyone blames the database, but there's plenty of blame to go around. Well, what do we mean by code errors? Well, these are examples: long waits, poor iterations, unhandled errors, bad choice of data structures. So there's lots of reasons that we have code level issues. Now, what's different today? I mean, this was 2016. I would suggest that these issues and the importance of solving these issues has grown exponentially. All of you have pressure to deliver more in less time, more releases in less time, and the types of applications you're building are starting to change. More modern applications that have a variety of services with the advent of microservices, and it's a great thing, right? Because you've got these individual services that solve a specific problem. But now when you look at it, there's a whole lot of moving pieces in an application. So not only do you need to make sure you can understand when there is a code issue, but where is that code issue? So APM is really playing a role. Matter of fact, IDC says APM is now a requirement for applications in today's environment. Okay, so how do you solve for this? I'm sure many of you have heard of observability. It's not just a fancy buzzword for monitoring. Yeah, monitoring is part of it. The observability is really understanding what's going on with the application and also being able to get the right information you need so you can troubleshoot and then remediate a problem. So what people talk about when it comes to observability, traditionally you've heard of 3 pillars: metrics, traces, and logs. Well, I'm here to tell you that I believe there should be a 4th pillar to observability. We're not going to get into it today a whole lot, but that's the user experience. Having the inside server-side view of an application. And we're going to talk about that with metrics, traces, and logs. But having an understanding of the user's perspective of performance, the user's perspective of availability of an application, if you're really looking for comprehensive observability, you need to combine the outside in, the client side, which is the user experience, with the inside. So metrics, time series metrics, representing infrastructure and application data, providing knowledge of the application's behavior. So those time series metrics can tell you, hey, something is not performing the way it normally does. I've got an issue. I need to dig into it. Now with the traces, I get this visualization of the end-to-end path of the entire request, breaking down that performance for each service, making up a distributed transaction. And with modern applications, 10, could be 20, there could be 30 services that are traversed for a transaction. What Adam's going to show you later is based on a hotel billing application that has, I think, 8 or 10 services associated with it that make up that application. So being able to visualize end-to-end that path and being able to identify where the issue is and which service is very important. And then, of course, logs. I don't know, for those of you who are CSI fans, logs are typically known as the evidence, right? A log is a timestamp record of discrete events that happen over time. So between having the time series metrics that give you a sense of what's going on, the traces giving you a visualization to dig down end-to-end throughout a transaction, and then the detailed information you get from specific logs, together that provides really strong observability. Again, not just monitoring, but the capability to know what's going on and having the information you need to troubleshoot. And again, we won't talk about it anymore today, but the user experience, we believe, is definitely one of those pillars. So let's do a little more deep diving. Let's talk about tracing now specifically. And there are multiple components. Here you see a typical waterfall trace. You get that end-to-end behavior I just talked about in real time, whether it's in production or test. And this is really important. Using APM in a test environment prior to production is becoming a really big thing. As we talked about earlier, you don't want to get application out there with bugs in the field. And, it happens and you need to be able to address that. But be able to use tracing, for example, to really understand what's going on, whether you're in production or you're in the test environment, can be very valuable. When we talk about having these multiple services and tiers, be able to understand the impact of upstream services on downstream resources is another thing the waterfall provides. And then, of course, drilling down to inspect request state and debug performance impact with trace timelines. So very powerful capability for those who are intimate with the application. Live code profiling. This is another level associated with tracing that can tell you if a slow transaction is caused by the framework, third party, or maybe it's your code specifically. It enables you to identify what slow method was introduced during regression, enables you to fix it before going into production. So this is specific to leveraging code profiling before you go out there live. Code profiling is traditionally separate from tracing. In our tool AppOptics, we've actually combined it with tracing, which enables you to find the slow service and then the slow function that only would have occurred in a real-world environment. So again, another powerful part of the tracing elements to troubleshoot. There's a third element connected to services and tracing. It's called exception tracking. Being able to provide a summary of the exceptions happening within the context of a service. So if you've got 8, 10 services and you're drilling down, in this case, is showing an example of a booking service, understanding not only the summary of the exceptions, but what's the volume, when did they start, then being able to view a stack trace and understand which endpoints in the application were throwing the exceptions. So here you're talking about traces, code profiling, exception tracking, all three of these components. And let me tell you, if you're an application developer, if you own the application, you really understand that application, all three of these are very powerful tools that can help you troubleshoot issues, again, whether you're in test or in production and you're shooting a bug. Now, with today's applications and the demands on all applications to be up and running, all the time. There's no such thing as 99.99 whatever. I mean, the expectation is things are going to just keep running. Well, there's a variety of people that need to be involved, and not everyone's going to have that intimate understanding of the application. So we really need to see how can you leverage an APM to groups beyond, say, the developer of the code. So now I'm going to kind of shift to talking about removing the complexity. This still talk about metrics, traces, and logs, but how can I take a step back and look at these things and say, how can not only I make this even easier for that developer, how can I make this usable by a variety of different skill sets, whether it's an SRE, whether it's even IT operations. So, you get thousands of metrics and all sorts of metrics you could be looking at. But what are those key metrics that help me understand, do I have a performance problem, or if the errors are impacting my services? Let me get there, and then I've narrowed this down, and I can get it in front of somebody who can take it to that next step. The traces, as we said already, are very powerful, but they can be hard to understand. You don't really know what to do with them unless you really understand the application. And even if you do understand the application, time is critical. So the more you can shortcut where the issue is, the better off you are. And then logs. Again, logs are awesome, especially for troubleshooting an application. But depending on how many log lines you're creating, thousands, you could be millions of them, you'd be searching through a log and you have a suspect log line. Well, the thing you're going to do next is try to find all those logs associated before and after to try and see if you can figure out what's going on. But that can be a challenge. So what I want to do now is I'm going to pass this over to Adam, and he's going to show you how taking an APM tool, not only can you leverage those things we talked about, but how can we remove the complexity and make this product available or APM available to a broader audience and also help the teams kind of work together leveraging a common tool. Adam, why don't you go ahead and take it away?
Perfect. I will share my screen here as soon as I am the presenter. Okay. So, as Pete said, the APM tools have historically been complicated. We have done a lot of work to try and make APM tools easier to understand, make the data and the information a little bit simpler, and really make the tools just more approachable by more people on your team. So not only the architect or the really advanced developer, but really everybody on the team. And we're actually going to dive in right away to kind of look at a troubleshooting flow and just to look at just how easy it is. So right now, we've got a bunch of different services that make up our application. And our kind of made-up workflow here is, imagine you have an application where your users need to search for something. In the example we're going to look at, it's a hotel booking site. So there's a search bar where the user can search for a hotel, put in some different criteria, etc. And imagine that your users are opening support tickets and saying, hey, search is really slow right now. It's taking a long time, and those users are having a bad experience. Maybe it's even affecting your business. Ideally, if you use AppOptics, you would actually know about that before your users do. You would have an alert set up. But we'll just go through the flow of, hey, your users are calling in saying that the search is slow. So we can click into our search service here. Right? It was named that. It was easy to find. And right away, we just have a notification at the top that says, hey, this service is spending most of the time making queries to MongoDB. Right? So it's literally one click, and we already have information that, hey, the slow component in the search service is the database. We already know that. We've got more context, so we can answer questions of, hey, is this service always slow, or did something just change? So we've got things like response time compared to a week ago. So actually looking at this metric, it seems like it's always just a little bit slow. There's nothing really happening right now. Request volume also compared to a week ago. A lot of times if there is a performance problem, it's because there's just a lot of people using your site. So that will be very clear here. Error rate was flat, and then CPU utilization is actually very high. But all these metrics are compared to a prior period. So then even if you're somebody like a support rep for a company, you can come in here, look at this search service and understand, hey, something changed, is something bad happening right now, and what's slow in this service. So a lot of context just in a simple interface. The next step might be, I understand that the search service is waiting on the database, but I need a little bit more detail on that. I need to kind of understand what in the database could be making this slow. And that's where traces come in. So on the previous page, we were looking at, kind of metrics over time. But one of the nice things about AppOptics is you can come in and look at actual requests from your users and see what was taking a long time. So here we basically have a scatter plot or heat map of requests from our users. And all we have to do, we can actually just draw a box around some of the slow ones and then take a look at a real example. So this is a request from a user. It took place 37 minutes ago, and the response time was 600 milliseconds, so just over half a second, which could feel like a long time when you're doing a search. So when we click through onto this, remember we were coming through and we were wondering, hey, why is the search service slow? Why are users having a bad experience? And now we're looking at an actual request, one of the slower ones from our users, and we can see that, hey, 97% of the total time was spent on these database calls. Right? It basically completely answered our question. I know our users were having a poor experience and the site was slow because of these specific database calls in our search service. Right? So just a few clicks, we went from wondering why a service was slow, why our users were having a poor experience, and then this information is basically handed to us. Let's take a look at a slightly more complicated example. So in the last one, very straightforward. It was the database's fault. We got the queries and we had our answer. The transaction that we're going to look at in this example is a little bit more complicated because it uses distributed services. Normally, when you have distributed services, this demo site we're looking at, it runs in Kubernetes, it's in containers. It's hard to piece together that information to understand what could be slow and what could be causing the problem in such a complicated environment. But we're going to do the same thing. We're going to go look at a trace. Say, hey, this trace is actually almost 3 seconds. So this is a user coming, looking at our hotel booking site, and the request took 3 seconds to come back to them. In using modern technology and using your web browser, 3 seconds is a very long time to wait. That's a frustrated user. So now when we clicked on this one, we see that, that almost 3 second, that time there again. And in this case, we're actually spending 98% of our time waiting on service calls to a downstream service. So, we came in our web tier service, which our end users are interacting with, and right off the bat, we know, okay, we're spending 98% of our time waiting on these service calls to return. And if we take one of these that are 911 milliseconds, we can actually click on that, and through distributed tracing, now we're looking at the performance of that downstream service call to our booking service. And again, what do you know? It's waiting on the database. So simple and easy information for all your team members to kind of work together and understand what's slow. And if you have a developer on your team or an architect and they're looking for even more detail, saying, hey, why are we making these database queries? Can we see the logs? Can we get right down to the code level? We still have that information. It's just a click away on the details tab. So we were just on the summary tab where it's kind of plain English and everybody can understand it. And then the details tab is, hey, right down to the code level, we can look at stack traces, we can follow our code execution, and we can really understand what's going on. So a little bit more of an advanced user. And taking that one step further, if if a developer isn't happy with just looking at the code execution and maybe looking at some stack traces, we actually have logging built in as well. So kind of going from a summary, high level, down to kind of a code level view, we can also click on this search logs button, and we have an integration with Loggly in this case. And these are the exact logs from that transaction we were just looking at. It's not a guessing game of logs that were happening around the same time. These are the specific logs from the transaction we were looking at. So if you think about it in kind of an easy and simple use case down to the most advanced, we have all of it kind of in 3 stages. The summary view of why a transaction was slow, down to the details and the code level visibility, and then right down to the logs from that transaction. So this really helps your entire team work together. And maybe there was somebody on your support team looked at the summary view and said, hey, this thing is slow because of the database. Then a developer came in and said, yep, I can see the database calls. Also, here are the log messages that I wrote, so I have full context in understanding the issue. The one last thing I want to mention is this really all comes together in dashboards as well. So imagine your team had identified an issue. Maybe there was a slow query that you want to watch for next time, or maybe you just want some high-level metrics on a dashboard. Everything we looked at and everything you can see in AppOptics, you can also put on a dashboard. So you can pull in infrastructure metrics. We have metrics with integrations with Azure and AWS, all the APM metrics that we've seen, and these are fully customizable. So if we want to adjust the size of the charts, add a new chart, completely customizable. They're great to put up on a dashboard so your whole team can have visibility into your applications and the infrastructure that supports them. That's the end of our kind of structured demo. Now I'll open it up for Q&A. Pete, do we have any questions on that?
We do. We've got about 5 or 6, so let's get going on. There's some good questions here. One of the first questions, and by the way, guys, while we're going through the Q&A, we are going to throw up a couple of poll questions, and this is really related to if you'd like to follow up with us, it's a way for you to let us know. But first question I have, Adam, says, which technology or method does it use, I'm assuming AppOptics, to know that most of the time, sorry, I keep losing this, most of the time is wasted making database consoles. So what technology or method is AppOptics using to know that most of the time is being wasted making database consoles or queries?
Good question. So for APM, for us to get the data that we had, we have libraries for about 8 different languages. So a lot of the stuff we were looking at was in Java. So we have a Java agent that basically needs to be included with your Java application that when it starts up. And when we do tracing, we basically measure and we have insight into outgoing database calls, remote calls, and all that stuff. And what we do is we basically summarize that on the AppOptics backend. We kind of put it through some different logic, and we're able to come up with those kind of root cause and saying, hey, this is where you spent your most time.
Okay, great. Another question we have, Adam, and I answered this partially, but I think you can do a better job on this. What is the capacity of AppOptics for traces? And the example, it says, would it be able to trace all the traces for budget rent-a-car lookups, tens of thousands per hour, for example?
Great question. So Peter probably answered this a little bit, but AppOptics does work on a sample rate. So when you purchase AppOptics, it comes in packs of 10 hosts, and for every 10 hosts you get 100 traces per minute. For the most part, that's enough for most people. You do have the option that you can purchase trace packs by themselves and just get essentially more coverage on your applications. But we have customers that do huge numbers. I think we have a customer that does about, I think it's about over 1,000 requests per second. So there's certainly customers out there with large volume, and they get enough visibility with this sample rate method.
Okay, thank you. Another question. How do you use tracing together with code profiling?
Yeah, great question. Actually, I think I'm not sharing my screen anymore here.
Yeah.
But that's okay. So code profiling it's tied directly to the traces. So when we were looking at the summary there, and it said, "Hey, these are the database calls that are slow. And this is where you spent the most of your time." If it wasn't the database, like maybe you just have some custom functions, or I don't know, you're turning some numbers into a CSV and you have some job that runs to do that. Instead of seeing the database calls there, AppOptics will just say, "Hey, you spent most of the time in the local application, and here are the slow functions that took place." So it just hands in hand with tracing. Whatever is the slow component will give you the information you need to really dive in and understand what's the slow thing and how to fix it.
Okay, we've got 2 or 3 more here. Let me try to fire through these. Can you use other log management products with AppOptics?
Yeah, great question. So when we clicked on the search logs button and it took us from a trace down into Loggly, basically what we're doing is we are injecting a trace ID, so like a unique ID to that request, into our logs, and we're able to match those in Loggly. If you happen to be using a different logging tool, or maybe you're even just logging to the local machine, you can still use that functionality. You can still have AppOptics add this request ID to your own logs.
Okay, just got 2 more questions here. How far back can you go to compare a service issue?
Yeah, so on the service summary, when we were looking at, it said, hey, you're spending most of the time waiting on MongoDB, showing us our latency and error rates over time. You can go back 18 months. So you can go back a very long time and look at your historical performance.
All right, and the last question, explain how an AppOptics or APM can help enable teamwork between groups.
Yeah, it's a good question. That's a big part of this kind of simplifying APM and making it easier to use. We did a lot of user research, kind of the way that SolarWinds works. We talk to our customers and make sure that the data and the products make sense to them. And one of the things we wanted to make sure is, when somebody comes in and looks at a trace and looks at the service summary in AppOptics, whether they're on the support team, they're a manager that's never seen AppOptics before, we wanted to make sure that the data made sense to all of them, and they were confident that they could look at it, understand what the problem was, and had the confidence to share that with a team member. So through our user research, that's really what we accomplished. And we're kind of happy that that teams are comfortable working with that data together now.
All right, great. Well, look, there's one question that's being asked and answered, but I'm going to share that with everyone. Now, I apologize. I should have said this from the beginning. You're all going to get the slide deck. You're all going to get the recording, and you'll have that capability. So if you want to go back over this or share this with your closest and dearest friends, that should be going out to you in the next day or so. Well, look, we're out of time. I will leave you with this. In the slide deck you get, what you see here is the products that make up the SolarWinds APM suite. Of course, we talked about SolarWinds AppOptics. I briefly mentioned user experience monitoring. We do that with a product called SolarWinds Pingdom. And then we showed an example of SolarWinds Loggly, log monitoring, but there are other products like SolarWinds Papertrail, and as Adam said, you can use other products. But in case you're interested in learning more about the suite, these have hot links, and then there's also a link to our APM suite site that kind of gives you a high-level overview. If there's no other questions, and I think we're good, thank you, Adam. Awesome job. And thank you all for sharing 30 minutes with us. I hope you found it of value, and hope to talk to you again here sometime in the future. Thank you.